You said, hey, this is a hacky implementation. You said the initial implementation was actually a lot cleaner. So is your ask to actually reconsider to the DPDK community, or what's your advice?
I was proposing to add a new library, but because of all the maintenance costs and all the validation effort that would have to be repeated to introduce that library, that's the basic reason why it was rejected.
Okay.
So I guess we are getting close to the end. So we get a talk from Anthony from Emutex about Docker's VNFs. That'll be interesting talks. So we move more to some high-level applications. So going to the end of some low-levels, atomics, and so on. So that could be an interesting topic. So you are going to talk about Lib1Net library. Frankly, I've never heard about that. So interesting introduction. Thank you.
Okay, we have it. Thank you. Okay, so you've made it to the last presentation of this DPDK Userspace event. So I'm here to talk to you about a new library that we've been developing. So my name is Anthony Fee. I'm with Emutex. And this library, well, in particular for this discussion, I'm going to talk about how this Lib1Net library based on DPDK can optimize VNF performance and maximize VNF density in enterprise edge solutions. So as this is my first talk at the DPDK event, I'll just give you a little background on who I am and who Emutex are, followed by some information about enterprise edge characteristics for these particular devices, these solutions. I'll talk a little bit about the Lib1Net library, what it is, what are its benefits to VNF deployments in this area. And finally, just go through some of the more important features that we think can help in this area. So, yeah, as I said, my name is Anthony Fee. I'm a principal network software engineer at Emutex in Madrid. So we have our headquarters in Limerick in Ireland. Regarding my personal DPDK experience, I'm currently a developer of high-performance DPDK-based network applications and VNFs. A long time ago, I was co-author of the initial vhost user example application alongside Tommy Long and under the guidance of Ray Kinsella in Intel, including the integration of that vhost user interface with OVS DPDK. Emutex are involved in the development of high-performance network applications built with DPDK, specifically optimized on Intel architecture, and the development of Linux kernels, drivers, and distributions for embedded systems. So, very simple and colorful graphic here to keep you all awake. So just going from right to left here, so we know the telco cloud, it's based on data centers, big servers, lots of resources, with VNFs generally being virtual machine based. With the emergence of 5G now and the requirements that's bringing around latency and throughput, there's an emergence of intelligence that's required at the telco edge, at the edge of the telco network. This is not as spacious and as many resources available as you would have in the telco cloud, so even physical space is limited in some of these areas. And so the VNFs themselves tend to be more lightweight, and it's trending more towards Docker containers in that respect because these are more lightweight. The VNFs themselves, it's not just a case of developing an application, putting it in a container. There's all this life cycle management and health checking that needs to be addressed as well, and these requirements are currently being defined. But it's not quite there yet. But there's a market that will emerge here at some point. But for today, I'm focusing on the enterprise edge, particularly these kind of single box solutions that sit between the telco network and the enterprise network, such as security appliances. They tend to be single vendor solutions where the VNFs are owned by the vendor themselves or created by the vendor themselves. And so they'd be considered as trusted. So as well as being single vendor, the hardware cost has a significant impact on the solution. So hardware is required, but these vendors are not hardware engineers of any sort. Maximizing network throughput is obviously a challenge, but DPDK, of course, helps with that. Service chaining is quite common. So by service chaining, I mean that you have one VNF transmitting directly to another, which in turn will transmit to another through a full chain of VNFs. And as I mentioned, it's trending towards the use of Docker containerized VNFs. So how can you maximize network packet throughput and density in the enterprise edge solution? And what we're proposing is you use Lib1Net with DPDK and Docker. So what is the Lib1Net library? It's a lightweight DPDK-based software library that simplifies the integration of DPDK packet acceleration. So similar to what was presented by Keith Wiles at this event in Dublin last year, there's an abstraction here that takes configuration and optimization of using DPDK away from the user to give an easy path, in particular to new users, or to give another option to users who particularly don't want to know much about this configuration. So it exposes a simplified API focused on VNF requirements. And as I mentioned, right now it's targeting enterprise edge Docker containerized VNFs. So the benefits in this area are that it abstracts the VNF applications from the DPDK configuration, and it optimizes packet receive, polling, and transmission, as I mentioned. So I'm going to get into that a bit more in later slides. Also, it maximizes hardware utilization for service chaining, in that you can fit more VNFs on your particular hardware solution, or perhaps you can go with a smaller form factor solution to, with the same application, basically. Also, we look to simplify port management through JSON configuration. So Lib1Net itself is configured through JSON. And standardizing as well how configuration is provided to VNFs at both init and runtime. So how can you configure DPDK to maximize packet processing performance of your VNF? So we all know, at the moment, everyone in this room knows how to configure DPDK. You need to configure ports, memory in an optimized way for your solution. But generally, a lot of the people tend to go with default values, or maybe some range depending on your latency or throughput requirements, but DPDK tends to be about packet throughput. So Lib1Net does this for you by looking after the configuration of memory, configuration of ports, and the initialization of DPDK. So it is a true abstraction in that it's limited how much the user can do here. So if you really need to do something more complex, then DPDK might be the answer for you. But if you're looking for the standard DPDK, what you're focused on here is maximizing throughput, simply connecting to network interfaces, then this does that for you. What is the most efficient method of receiving and transmitting packets? Again, we're all very familiar with this, with DPDK and its polling mechanism, that you receive in bursts. This is the most optimized way to receive, and you transmit in bursts as well. So we've introduced an abstraction here where this is handled by the library itself. And the application layer can register an RX callback. So Lib1Net will continue to receive in bursts, so continue to get that optimization, but pass these packets up through an RX callback. And on TX will queue until a threshold is met, a burst size, or a timeout occurs, and that burst will be transmitted. So in service chains in particular, as I mentioned, I'm kind of dealing more with trusted service chains here, as opposed to untrusted. So this would be one of many possible configurations where you would have your VNFs. There's no routing between them. It's just one VNF into another, going through a virtual switch with memory copies occurring between them, which obviously is expensive, but the virtual switch itself taking up valuable resources that particularly in these kind of devices can be scarce. So ideally, for this particular type of configuration, you want to free up those resources. So Lib1Net does this using the Lib1Net link interface, which is based on DPDK shared memory. So it enables zero copy through the full service chain. Now, obviously, this is a security concern because you're sharing all this memory between all these VNFs. But as I mentioned, they're trusted. It also hides the whole primary secondary process thing that DPDK has. So we allocate one as a service chain master that handles the setup of all these interfaces, but that's done behind the scenes. So it's up to Lib1Net to detect whether it's a primary or secondary process. And that allows from packet being received at the initial interface, the whole way through the service chain, right to the end. If that packet comes through, it's the same buffer that arrives to that final interface. This is how to attach network interfaces to specific application ports. So this is just something that's repeated by applications that we decided to include. Basically, at init time, at Lib1Net init time, you pass the configuration structure, including a definition of your ports with some particular fields, one of those being the name of the port. And all we do here is allow the user to define what kind of devices they're attaching to that particular port at runtime, at init time, through a JSON configuration file. So you name your port, you say it's DPDK PCI, DPDK MEMIF, and the name of the interface itself for the PCI ID. And that will, Lib1Net will then connect those for you. So how can you manage your VNF configuration? Every application needs to be configured. Depending on your environment, you may need to set different parameters for your application. So we provide two methods for that, one for init and one for runtime. At initialization time, as I mentioned, we have this JSON configuration file. And what we've done there is reserved a field just for the application. And at runtime, that's completely custom, so you can pass whatever you want to that. You can pass another JSON object. It could be plain text, whatever you want. But Lib1Net's job in this case is to pass that configuration through to the application through a configuration callback. And it's up to the application itself to then parse that. So because every application is different, we can't do much more than that except pass that information to the application and try to make it some way standard so all your VNFs are behaving the same way. At runtime, this particular management port here, similar to a standard network port, we allow you to define whatever type you want. So if it's DPDK PCI, MEMIF, whatever you want, that management port then does the same thing. It passes these messages up directly to the application, and it's up to the application to then parse that. So this is what your edge solution might look like. So each VNF configured in the same way, using a JSON configuration file. Some of that being used by Lib1Net and some being passed directly to the application. So Lib1Net will look after your DPDK configuration and optimize the packet handling as best it can. It provides a zero-copy interface for trusted network training, and it provides application configuration to the VNF in a number of ways. So by developing these edge solutions with Lib1Net, you benefit from increasing your VNF density, particularly when service chaining. So as I mentioned, by getting rid of that vSwitch, you're freeing up cores, which can increase capacity or can allow the same application to be run on a smaller form factor device, which in turn impacts cost. Maximize network throughput using the Lib1Net link interface for trusted service chains. Configuration of DPDK and optimized RxTX packet handling, and a simplified mechanism to pass these configurations to the VNFs. So right now, we're working on, I suppose, hardening this further, so we still have testing to be done. We still have some performance optimizations to be put in place. And one of the things that we really want to do is develop performance reports around this to compare this to raw DPDK. So obviously this is an abstraction, so there's going to be a loss of performance, but it's a matter of providing that information so that people can make an educated decision on whether they really need more and they need to spend the time getting to know DPDK better and its configuration or not. We'll also be looking at expanding this in other ways in the future, but just one talk today from Chris and Dave on the power management was a very interesting one, because it gives an opportunity here to allow Lib1Net to handle those busyness cycles and determine how busy an application is, so the application never needs to be aware of that. And yeah, that's everything, so thank you, and any questions?
I I have three questions, actually.
Okay, very good.
The first is there any orchestration in Lib1Net, or is it just like providing an abstraction of the resources available to the
So right now it's an abstraction, but the plan is, so this is, I suppose, what you call the first pass. We want to be able to plug into these orchestration systems. Particularly what we want is for these type of vendors to be able to develop their applications. And as Lib1Net evolves, as VNF requirements are being defined, then the application itself will also evolve. And so what we want to do is be able to plug into those existing orchestration systems.
Second question, can I be so bold, since I didn't ask any other questions today?
Yeah.
What? The next question is the code upstream?
Not yet. So as I said, because we want people to contribute to this at some point, so we want everything at as high standard as possible to make sure that it continues to that standard. So we're working on that at the moment, but in the coming months we'll be hoping to make this.
Okay, so you will start a new project, or will you?
Yes, this is separate to DPDK.
Okay. And the third is the zero copy.
Yes.
So how are you managing, how are you building boundaries about that, around that? How are you doing that? I mean, obviously,
When you say boundaries?
Well, so that, just explain the zero copy
Okay.
more.
So it's using DPDK rings. And it's basically, if you're a primary process, you're in charge of creating that and managing that memory. And then everyone else is secondary processes that get access to that memory. But as I said, it's a single block of memory that's available to all the VNFs.
Going to map the rings.
Exactly.
Okay.
So if we were just to share it between VNFs, then you'd be using the MEMIF interface or something like that.
And are you targeted for low-end devices too? Like is it Intel architecture only, or does it include ARM? How about Atom? Things like that?
Well, at the moment the targets are Intel because that's what we're testing on, but really we'd want to be supporting these kind of devices as well going forward. But there's quite a bit of work to get to that point, but yes, that would be of interest.
Thank you.
Yeah, okay, thank you. I have two questions. First is, you mentioned you are using Docker, but I saw the VNFs owning 4 or 3 VMs. So how many Dockers you are using for your Lib1Net?
Well, the library itself is just part of the application, so that's up to the developer of the VNF. Well, it's going to be a single VNF per Docker container, basically, so one instance of Lib1Net.
Yeah, so for the project, how many containers you want to deploy? Things looks like not too many containers here.
Yeah, well, this is just, I envisaged a smaller screen here, so I could have a lot more VNFs, but in the end it's very big.
Okay.
But yeah, that's I suppose it's limitless, really. It depends on the resources of the device. So that's what's going to limit how many VNFs you can have on your system.
Okay. Yeah, second question is about, in this picture that the port 0 is in the first container. And so what's the virtual interface between the container?
This is, it's a new interface that's part of Lib1Net, but it's based on DPDK rings and sharing that memory. So this is, it's not something that's there at the moment. It's new.
So it's a virtual device?
Yeah, it was possible before, but what this is giving you is the ability to decide whether you want a device like this or you want a physical interface attached to a particular port. So it's kind of providing that abstraction. So if you want to use memory in this way at the moment, you need to program or develop your application in that way to expect that kind of device.
Yeah, I saw that there are 2 ports. Do you consider any VF, the virtual function, between the...
Well, I mean, yeah, you could attach, I mean, this is up to what you want to attach to those ports. So basically, whatever is supported by DPDK here is supported, as well as this link interface.
Yeah,
so whatever DPDK can connect to, then it's at the end of the day, it is DPDK based. It's DPDK at its core, with I suppose some enhancements for this particular area.
Okay. Okay, thank you.
Okay.
So if the service function chaining is going to be transparent, then there must be some addressing between those applications. So is this link just a direct link, or is it based on L2 switching to address the...
This link is just a direct link between the VNFs.
Okay.
So it's just a single ring with buffers being put on one side and queued and dequeued.
Okay, but is it a full mesh, or is it just one to another to another?
One to another in this case.
Okay,
so
so
that's
like
this particular
pre-configured.
scenario, but
Okay.
you may have like a partial service chain in your solution, which would still save you some resources based on not having to pass those packets to the virtual switch. So
Alright.
this is the full service chain solution, but depending on your architecture, it may benefit you, it may not. So it just depends on that.
All right. So so in this edge use case, the service chaining is predetermined, and you basically build the topology so
Yes.
that it serves the...
Yes, but you could do it
solution.
dynamically. So for example, the third and fourth VNF could switch, but it all depends on how you configure your application through the JSON configuration file. So it's up to you to attach a link port or a physical port or whatever other type of port you want.
Okay.
That's done at init time.
All right. Thanks.
But it can't be changed when it's up. Okay, thank you.